Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the simultaneous equations practice questions. And they're the simultaneous equations that are based on linear and non-linear simultaneous equations. And if you need any extra help on non-linear simultaneous equations, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 298, there's a dedicated video tutorial there on non-linear simultaneous equations. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one said solve the equations x squared plus y squared equals 20 and x plus y equals 6. So here we've got two equations. The bottom one's a linear and this is a non-linear. The top one's a circle actually, and that's a straight line. And we've been asked to solve these simultaneous equations. So what we're going to do is we're going to make either x or y the subject of the linear one here at the bottom, and then we're going to substitute that into the top one, the non-linear, and then we'll solve it. Okay, so let's make x a subject of this linear. So if we've got x plus y equals 6, if we want to make x a subject, we want to get rid of this y. So to get rid of this y on the left-hand side, we're going to subtract y and subtract y from both sides of that equation. On the left-hand side, we'd just be left with x. And on the right-hand side, we had 6. We're now taking away y, so it's going to be 6 subtract y. So we've made x a subject of this linear equation. Now what we're going to do is we're going to go to the nonlinear one, which is x squared plus y squared equals 20, and we're going to replace the x with 6 subtract y. We're going to substitute this in for the x. So instead of having x squared, we're now going to have in brackets 6 subtract y. Close brackets squared. So that's instead of x squared, it's now 6 minus y squared, because x is 6 minus y. And then we've got our plus y squared equals 20. So we've substituted in our linear into our non-linear, so we've replaced the x with our 6 minus y. So we've now got 6 minus y squared plus y squared equals 20. Now what we want to do is we want to solve this equation. So to solve this equation, we want to expand this bracket. So remember, whenever we square a bracket, we were multiplying it by itself. So it's 6 minus y, and then a bracket 6 minus y. Close brackets, then plus our y squared equals 20. Now let's expand our brackets. 6 times 6 is 36. 6 times minus y would be minus 6y. Minus y times 6 would be minus 6y. And minus y times minus y is then plus y squared. So that's 6 times 6 is 36. 6 times minus y would be minus 6y. Minus y times 6 would be minus 6y. And minus y times minus y is equal to y squared. So that's what we get when we expand those brackets. Okay, now we've still got our plus y squared. Let's not forget that y squared. And that's equal to 20. Okay, so now let's simplify this. So we've got 36. We've then got minus 6y, take away another 6y, so it's going to be minus 12y. And then we've got plus y squared, so it's going to be plus 2y squared, because y squared plus y squared is 2y squared. And then that's still equal to 20. Now we want to solve this. This is a quadratic. I'm just going to change the order slightly, so I'm just going to rearrange it slightly. So I'm going to put the 2y squared at the front. I'm going to then put the minus 12y then next, and I'm going to put the positive 36 at the end, so plus 36, and that's equal to 20. Just changing the order there, putting the 2y squared at the front, keeping the minus 12y in the middle, and putting the 36 at the end, just so it looks like what I normally expect a quadratic to look like. Okay, now whenever we still want to solve a quadratic like this, we want it to equal 0, so we don't want this to equal 20. So let's take away 20 from the left-hand side and take away 20 from the right-hand side. So on the left-hand side, we'll be left with 2y squared minus 12y. And then instead of plus 36, we're going to take away 20, so it's going to be plus 16. And that's now equal to 20 take away 20 is equal to 0. So that's what we wanted. Okay, so we've now got a quadratic equaling 0. So we want to solve this quadratic. Now, actually, before we solve it, we've got 2y squared minus 12y plus 16 equals 0. All of those terms on the left-hand side are divisible by 2. So I'm going to divide everything by 2 here. I'm going to divide everything by 2. So 2y squared divided by 2 would be y squared. Minus 12y, well, dividing that by 2 or half, and it would be minus 6y. And then instead of plus 16, we're going to divide by 2, so it's going to be plus 8 equals 0. So we've just divided everything by 2. So we've now got y squared minus 6y plus 8 equals 0. So this is a quadratic and we want to solve it. So we could try and factorize it and solve it, or use the quadratic formula, or use completing this square. I'm going to try and factorize. That's what I would normally do, and especially because it's a non-calculated question. So that's implying to me we should probably be able to factorize it. So on this left-hand side, let's put our brackets down, bracket, 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 and that's equal to 0. We've got y squared, so I'm going to put a y at the front of both brackets. Now we want to find two numbers that multiply together to be 8 and add together to be minus 6. So I'm thinking minus 2 and minus 4, because minus 2 times minus 4 is 8, negative times a negative is a positive, and minus 2 plus minus 4 would be minus 6. So we've now got y minus 2 bracket y minus 4 equals 0. And let's just check that. Y times y is y squared. Y times minus 4 will be minus 4y. Minus 2 times y will be minus 2y, so that's minus 6y altogether. And minus 2 times minus 4 would be minus 8. So that's fantastic. So we now want to find our solutions. So these two brackets multiply together to be 0. That means that either bracket is equal to 0. So either here, y is equal to 2, because 2 take away 2 is equal to 0. And here we would have that y is equal to 4, because 4 take away 4 is equal to 0. So that means that y is equal to 2, or y is equal to 4. So with these nonlinear simultaneous equations, they quite often have more than one solution. So whenever we're dealing with this situation, which is a straight line and a circle, it means that this straight line is crossing the circle at two different points. So here we've got y is equal to 2 and y is equal to 4. We now want to find a value for x. So we're going to have to substitute these values into one of our equations, and I think the linear is obviously the best one to choose. So we get x plus y is equal to 6. So x plus y is equal to 6. So when y equals 2, so whenever we look at this one, when y is equal to 2, we're going to have x plus 2 is equal to 6. So if x plus 2 is equal to 6, so x plus 2 is equal to 6. That means that x is equal to 4. So x is equal to 4, because if you take 2 away from both sides, you're going to get x is equal to 4. So it means whenever y is equal to 2, x is equal to 4. So that's one of our solutions. And then we've got when y is equal to 4, our other solution, when y is equal to 4, we're going to substitute that into here. So we'd have x plus y, so it's going to be x plus 4 is equal to 6. And then if we take away 4 and take away 4, we get that x is equal to 2. So whenever y is equal to 4, x is equal to 2. So there are solutions, that whenever y is equal to 2, x is equal to 4, and whenever y is equal to 4, x is equal to 2. So let's write that down. And that's it. I've just written down whenever x is equal to 4, y is equal to 2, or some people like to write and, whenever x is equal to 2, y is equal to 4. So there are solutions, and that's it. Okay, let's have a look at our next question, question number 2. So question number 2, we've got these equations. We've got this xy is equal to 24. So x multiplied by y is equal to 24. And then we've got our linear equation, x equals y take away 2. So we want to solve these simultaneous equations. So we want to make either x or y the subject of the linear, which has actually been done for us. And we're going to substitute that into the nonlinear. So instead of writing xy is equal to 24, we're now going to substitute in, instead of x, we're going to write y minus 2. So we're going to substitute in y minus 2 for this x. We're replacing this x and we're going to write y minus 2. So that would be y minus 2 instead of x, and then we've got our y is equal to 24. So here we've got y minus 2 multiplied by y is equal to 24. And actually I'm just going to put the y in front of this bracket. So we've got y bracket y minus 2 is equal to 24. So I've just changed the order of that multiplication there. Okay, now we're going to expand our brackets. So y times y is y squared, and y times minus 2 will be minus 2y, and that equals 24. And now this is a quadratic, we want it to equal 0, so let's take away 24 from both sides. So if we take away 24 from both sides, what will we get? So on the left hand side we'll have y squared minus 2y minus 24, and on the right hand side we'll have that's equal to 0. So we've now got a quadratic that we can solve, and hopefully we'll be able to factorize it. Because it's a non-calculator question, hopefully we should. So we're going to put bracket, 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 bracket equals 0. It's y squared, so I'm going to write y and y. So we're now looking for two numbers that multiply together to be minus 24 and add together to be minus 2. So I'm thinking minus 6 and 4, minus 6 and plus 4. Because minus 6 times 4 is minus 24, and minus 6 plus 4 is equal to minus 2. So we've got these two brackets that multiply together to be 0. We now want to see what the solutions are. So for this bracket, y will equal 6, because 6 minus 6 is equal to 0. And here, y is going to be minus 4. Y is equal to minus 4, because minus 4 plus 4 is equal to 0. So we've got our two values for y. Now let's find our values for x. So x is equal to y minus 2. So we're going to substitute these into that equation. So when y is equal to 6, we're going to have x is equal to, instead of y minus 2, it's going to be 6 minus 2, 6 minus 2, and that means that x is equal to 4. So whenever y is equal to 6, x is equal to 4. When y is equal to negative 4, then we're going to have x is equal to y minus 2, so it's going to be minus 4, so instead of y, minus 4, so minus 4 minus 2, and minus 4 take away 2 would be minus 6. So whenever y is equal to minus 4, x is equal to minus 6. So there are solutions, so let's write them down. And that's it. I've just written down our solutions, that x equals 4 and y equals 6, or and, some people like to write and there, x equals minus 6 and y equals minus 4. So there are solutions. And if we were asked this question, instead of being asked to just solve these simultaneous equations, we were asked to find the coordinates of the points where this straight line meets this graph here, the answers would be the points 4, 6 and negative 6, negative 4. So that means if you're asked the question in terms of finding where graphs intersect, that you can actually find your coordinates. And that's it. Okay, let's look at our next question, question number 3. Okay, let's have a look at our next question, question number 3. So question number 3 says, solve the simultaneous equations 2x minus y equals 7 and xy equals 15. So we want to solve these simultaneous equations, so we want to make either x or y the subject of the linear. Now in terms of this, we can either make x the subject, but that means we're going to be dividing by 2, or we can make y the subject, and I think that's what I'm going to do. So let's write it down, 2x minus y equals 7. So we're going to make y the subject. So I'm going to add y to both sides to begin with. The reason I'm doing that is to make the y positive. So on the left hand side, we'll just be left with 2x. And on the left hand side, we're going to have 7 plus y, because it's 7 plus y. Now we want to get the y on its own, so let's get rid of this 7. So let's take away 7 from both sides. So let's take away 7 from the left hand side and take away 7 from the right hand side. 2y, take away 7, will be 2y subtract 7. And on the right hand side, we had 7. We're taking away 7, so that's now 0. And that really means we're just left with y. So we've found, we can turn this around, that y is equal to 2x minus 7. So we've now made y the subject of the linear. Let's substitute that into the nonlinear. So instead of y, we're going to write brackets 2x minus 7. So here that means we're going to have x. And then instead of y, we're going to put a bracket and write 2x minus 7. And then close brackets. And that's equal to 15. Okay, so we've now got this. Now we want to solve this equation, so let's expand our brackets. X times 2x would be 2x squared, and x times minus 7 will be minus 7x. Just expanding that bracket there, multiplying both of these terms by x, and we've still got that's equal to 15. Now we want this quadratic to equal 0, so we don't want this 15 here, so we're going to take away 15 and take away 15. So on the left hand side, we'll have 2x squared minus 7x, and then our subtract 15. And on the right hand side with 15, we're taking away 15, so that's equal to 0. So we've now got a quadratic and it equals 0. It's a non-calculator question, so we're probably not using the quadratic formula. So let's try and factorize. So let's put our brackets down, bracket, 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 bracket equals 0. And because it's 2x squared, I'm thinking, well, let's try 2x and an x, so it will be 2x and an x. And we want to find two numbers that multiply together to be minus 15. And whenever we expand our brackets, we're going to get our minus 7x in the middle. So I'm thinking if we put the minus 5 on this side, because 2 times minus 5 would be minus 10x, and that's going to be quite useful in terms of getting close to this middle term. And then if I try the plus 3 there, because 3 times minus 5 is minus 15, which is fantastic. And let's just check this. 2x times x is 2x squared. 2x times minus 5 would be minus 10x. 3 times x is 3x, and if you add that 3x to the minus 10x, you'll get to minus 7x, and 3 times minus 5 is minus 15. So this is fantastic. Now let's solve this. So this bracket's easy. X is equal to 5. That's one of our solutions there. X is equal to 5. In terms of this bracket, we're trying to find whenever it's equal to 0, so I'm just going to write 2x plus 3 equals 0, just writing the bracket equals 0. Let's take away 3 from both sides, so on the left hand side we'll just be left with 2x, and then that's equal to minus 3. And let's divide by 2, and if we divide by 2 we get that x is equal to, and minus 3 divided by 2 will be minus 1.5. We could write it as a fraction, we could write it instead as minus 3 over 2, and minus 3 over 2 is the same as minus 1.5. It's up to you. So x is equal to minus 1.5 or minus 3 over 2. So there are two solutions for x. Now let's find the value for y. So remember here we made y the subject. Y was equal to 2x minus 7. So let's write that down, that y is equal to 2x minus 7. So we made y the subject of the linear. Now we're going to substitute in our values for x and we're going to find our values for y. So when x equals 5, when x equals 5, we're going to have y is equal to 2 times x, so that's 2 times 5, which is 10, subtract 7 still, and 10 subtract 7 is 3, so y is equal to 3. So whenever x is equal to 5, y is equal to 3, that's one of our solutions. And when x is equal to minus 1.5, y is equal to, well, let's figure this out. Y is equal to 2 times x minus 7, so it's going to be y is equal to 2 times x, so 2 times minus 1.5. So if we double minus 1.5, well, double 1.5 is 3, so double minus 1.5 would be minus 3, take away 7, so minus 7. And minus 3, take away 7 would be minus 10. So whenever x is equal to minus 1.5, y is equal to minus 10, so minus 10. So there are solutions. Our solutions are, so there are two solutions, x equals 5 and y equals 3, or x equals minus 1.5 and y equals minus 10. So there are solutions. And again, if you were given this question in terms of finding where this straight line intersects this curve here, the coordinates of those points will be 5, 3, and minus 1.5, minus 10. and that's it. Okay, let's look at our next question. Okay, so question number 4. So question number 4 says solve the simultaneous equations x squared plus y squared equals 17 and x plus 4y equals 0. So we want to solve these simultaneous equations. So we want to make x or y the subject of the linear, and I think making x a subject makes sense here. So we've got x plus 4y equals 0. We want to make x a subject, so let's take away 4y from both sides of the equation. So on the left hand side, well, we've got x, and then we're taking away the 4y to get rid of the 4y, so that's just going to leave us with our x. And on the right hand side, we had 0, we're taking away 4y, so it's going to be minus 4y. So x equals minus 4y. So now that we know what x is equal to minus 4y, we can substitute that into the equation of the circle. This is an equation of a circle. We can substitute in minus 4y in for x into that equation, and we'll be left with just an equation with y terms in it, and then we can solve it. So let's do that. Okay, so instead of x squared, well, we're writing minus 4y squared, but be very careful here. Because it's x squared, what we're going to do is instead of writing minus 4y squared, we're going to write in brackets minus 4y squared. It's very important that you put that brackets around that minus 4y, because if you just write minus 4y squared, it actually means something very different to minus 4y squared, all squared. So we've replaced our x with our minus 4y, and just making sure we put that in a bracket. Then we've still got our plus y squared, and that is equal to 17. So we've now got this equation, we now want to solve it. So we've got minus 4y squared. Remember, that means minus 4y times itself. So that's minus 4y multiplied by minus 4y. And a negative times a negative is a positive, and 4y times 4y would be 16y squared. So a negative times a negative is a positive, 4 times 4 is 16, and y times y is y squared. So whenever we square this, our minus 4y, we get that's equal to 16y squared. We've then still got plus y squared, and that's equal to 17. So we've now got 16y squared plus y squared equals 17. Well, let's add these together. 16y squared plus 16y squared, that's 17y squared, and that's equal to 17. We now want to find out what y is, so let's divide both sides by 17. So we're going to get the y squared, because if we divide 17y squared by 17, we're left with y squared, or 1y squared, which is y squared. And then 17 divided by 17 is 1. So if we divide both sides here, we'll get y squared equals 1. And now, if you've got y squared is equal to 1, that means that y could be equal to 1, or y could be equal to negative 1, because 1 squared is 1, or negative 1 squared is 1. So that means that y is equal to plus or minus 1. There are two solutions there. Either y is equal to 1, or y is equal to negative 1. So let's write that. Y is equal to 1, or y is equal to negative 1. So there are two solutions there, y is equal to 1 or y is equal to negative 1. Now we've got our values for y, let's substitute those into our equation, and I think use this version here, x is equal to minus 4y. If we substitute our values for y into that, then we can find our values for x. So when y is equal to 1, we would have x is equal to minus 4 times y, so it's minus 4 times 1, so minus 4 times 1, and minus 4 times 1 is minus 4. So whenever y is equal to 1, x is equal to minus 4, or when y is equal to minus 1, well, so whenever y is equal to minus 1, well, x is equal to minus 4 times y, so x would be equal to minus 4 times y, and y is minus 1, so minus 4 times minus 1, and minus 4 times minus 1, well, negative times a negative is a positive, and 4 times 1 is 4, so that would just be 4, so x is equal to 4. So there are solutions that whenever y is equal to 1, x is equal to negative 4, and whenever y is equal to negative 1, x is equal to 4. So let's write that down. And there are solutions that x is equal to negative 4 and y is equal to 1, or x is equal to 4 and y is equal to negative 1, and that's it. Okay, let's look at our next question. Okay, so let's have a look at our next question, question number 5. So question number 5 says solve the equations x plus 2y equals 3 and x squared plus 3xy equals 10. So let's make x or y the subject of the linear, and I think it makes sense to make x the subject of the linear. So we had x plus 2y equals 3. We want to make x a subject, so let's take away 2y from the left hand side and take away 2y from the right hand side. So on the left hand side, we're taking away 2y to get rid of the plus 2y, so we'll just be left with x. And on the right hand side, we had 3 and we're taking away 2y, so it's just going to be 3 subtract 2y. Okay, so we've now made x a subject of the linear. Now let's substitute that into the nonlinear. So instead of it being x squared, we're going to write 3 minus 2y squared, and then plus, and then we've got 3xy, so it's going to be 3 times this times y equals 10. So let's do that. So instead of x squared, it's this, so it's going to be 3 minus 2y, close bracket squared, just replacing the x or substituting this in for the x. And then we've got plus, And then it was 3xy, so it's going to be 3. Instead of x, we're going to write this, so in brackets, 3 minus 2y, close brackets, and then we've still got our y there, and that equals 10. Now I'm just going to move this y beside the 3 here, so we've now got 3 minus 2y, close bracket squared, plus 3y, bracket 3 minus 2y, close brackets, just moving that y to there, and that equals 10. Okay, so we've now got our equation, we now need to solve it. Before we can solve it, let's expand our brackets. So we've got this and we've got that. Okay, so remember whenever we've got a bracket squared, it means multiply the bracket by itself. So it's going to be 3 minus 2y, close brackets, 3 minus 2y, close brackets, because when you're squaring a bracket, you're multiplying it by itself. And then plus, and we've got our 3y bracket, 3 minus 2y, close brackets, equals 10. So now let's expand our brackets. 3 times 3 is equal to 9. 3 times minus 2y will be minus 6y. Minus 2y times 3 will be another minus 6y. And minus 2y times minus 2y, so that's going to be positive. A negative times a negative is positive. And 2y times 2y will be 4y squared. And then on here, we've got plus. And then 3y times 3 will be equal to 9y. And 3y times minus 2y, well, a positive times a negative is a negative. And 3y times 2y, well, 3 times 2 is equal to 6. And y times y is y squared, so it's going to be 6y squared. And that's equal to 10. Okay, so we've now got this, and it looks quite complicated, so let's simplify it. So we've got, let's deal with our y squared to begin with. We've got 4y squared, take away 6y squared. So that's going to be minus 2y squared. So that's dealing with the y squareds. 4y squared, take away 6y squared. That's minus 2y squared. Now let's deal with our y's. We've got minus 6y, minus another 6y, so that's minus 12y's. So minus 12y's plus 9y's would bring us up to minus 3y, so minus 3y. And then in terms of our numbers, we've just got our 9 there on the left-hand side, so plus 9. And that equals 10, so that equals 10. Now I'm just going to write this up here, so we've got our minus 2y squared minus 3y plus 9 equals 10. Okay, so we've now got to this point, but we want a quadratic we can solve, so that means we're going to want it to equal 0. So let's take away 10 from the left-hand side, and let's take away 10 from the right-hand side. So on the left-hand side, we're going to have minus 2y squared minus 3y, and then we had 9, but we're taking away 10, so it's going to be minus 1. And then on the right-hand side, 10 take away 10 is 0. So we've taken away 10 from both sides. Now at this point, we're going to want to try to factorize this. It's a non-calculator question, so hopefully be able to factorize. But we've got minus 2y squared minus 3y minus 1 equals 0. And this minus 2y squared, ideally I would like it to be 2y squared. Now one thing I could do is I could add 2y squareds to both sides, and then add 3y's to both sides, and add 1 to both sides of that equation. And that'll leave us with 0 on the left-hand side, and then everything on the right-hand side, that 2y squared, 3y, and plus 1. Or another approach you can use is, if you've got an equation like this, you can multiply everything by negative 1. So we can multiply everything here, all the terms by negative 1. So we can multiply all the terms by negative 1. So negative 2y squared times negative 1 would be 2y squared, because whenever you times by negative 1, you're changing the sign. Minus 3y times a negative 1 would be plus 3y. And minus 1 times negative 1 would be plus 1. And that equals, and 0 times negative 1 would still be 0. So you can multiply an equation through by negative 1, and that changes all the signs. Obviously with 0, it just stays a 0. So it changes all the signs. And as I mentioned, another approach that you could have used would be to add 2y squared to both sides, to add 3y to both sides, and to add 1 to both sides. And you'd end up with this on the other side, and then you could turn it around and it would look like that. Okay, so let's try and factorize this. So let's put our brackets down, equals 0. So we've got 2y squared, so it's going to be a 2y and a y. We want two numbers at times together to be 1, and whenever we expand our brackets, we're going to get our plus 3y. So that's now going to be a plus 1 and a plus 1. So that's our brackets. And let's check it. 2y times 1 is 2y, and 1 times y is 1y, and if you add them together, that's 3y, and 1 times 1 is 1. So that's it, we've factorized it. Here, in terms of this bracket, y will equal negative 1. And in terms of this bracket, I'm just going to go up here, 2y plus 1 equals 0. Taking away 1 from both sides would leave us with 2y equals minus 1. And then dividing by 2, we'll get that y is equal to minus 0.5, or minus a half. So that means that here y is equal to minus a half, or minus 0.5. So we've got our values for y. Now let's find our values for x. So x is equal to 3 subtract 2y. So when y is equal to minus 0.5, y is equal to minus 0.5. So here we've got x is equal to 3. Now we need to be careful here. So we're going to subtract, and 2 times y. So 2 times minus 0.5. And 2 times minus 0.5 would be equal to, doubling this would be equal to minus 1. So 2y, 2 times this is minus 1. So we're going to do 3 subtract minus 1. And 3 subtract minus 1, well, that'd be equal to 4 because we're a minus and a minus means we're going to add. So 3 plus 1 is equal to 4. So x equal to 4. So that means that one of our solutions is whenever x is equal to 4 and y is equal to minus 0.5, or our other solution, let's work that one out, whenever y is equal to negative 1. We need a bit more room here, so I'm just going to move things about a bit. Okay, so we now want to find our other solutions. So that's whenever y is equal to minus 1. So we've got x is equal to 3 minus 2y. So when y is equal to negative 1, x will be equal to 3. Subtract 2y, so subtract, and 2y, 2 times minus 1 will be minus 2. And then we've got 3 subtract minus 2, or 3 minus minus 2, so that's going to be x equal to 5. And let's just recap that. Whenever y is equal to minus 1, double minus 1, or 2 times minus 1 is minus 2, so we've got 3 minus minus 2, which is equal to 5. So that means that x is equal to 5 and y is equal to negative 1. And there are our solutions, and that's it. Okay, so let's have a look at our next question, question number 6. So question number 6, we've been given the equations 2x plus y equals 11 and 2x squared minus y squared equals 23. So in terms of this question, I'm going to make y the subject of the linear. So we've got 2x plus y equals 11. So we want to make y the subject. So let's get the y on its own. So let's get rid of this 2x. So let's take away 2x from the left-hand side and subtract 2x from the right-hand side. So if we take away 2x from the left-hand side, we'll just be left with y. And on the right-hand side, we'll have 11 subtract 2x. So we've made y the subject of this top equation. Now what we're going to do is we're going to substitute it into the second one. So we had 2x squared minus y squared equals 23. And instead of the y, we're going to write 11 minus 2x. So that's going to be 2x squared minus, and then in brackets, 11 minus 2x, close brackets, squared. And then that's equal to 23. Now let's expand our brackets and simplify. So it's going to be 2x squared subtract. And then what I'm going to do is I'm going to write the bracket out twice. So 11 minus 2x. And then again 11 minus 2x. Because we're squaring the bracket, we're multiplying the bracket by itself. And then that's equal to 23. 2x squared subtract. And now we're going to expand these brackets. So I'm going to put a square bracket just so that whenever we expand our brackets, we can see what we get here. So 11 times 11 will be 121. 11 times minus 2x will be minus 22x. Minus 2x times 11, that'll be minus 22x. And then finally, minus 2x times minus 2x, that's going to be plus 4x squared. And then close brackets, and that's still equal to 23. Now let's simplify this. So we're going to have 2x squared subtract, and then in our square bracket, let's simplify this. So we're going to have 121 subtract 44x, so subtract 44x plus 4x squared. Close brackets. So just simplifying this, simplifying the two terms with x's in the middle, and that equals 23. Okay, so we've now got 2x squared subtract all of this. So that would be, we've got our 2x squared, and then we're subtracting 121, so subtract 121. And then we've got minus 44x, that'll be plus 44x. And then we've got minus 4x squared, so that'll be subtract 4x squared. And that's equal to 23. So there you just need to be careful whenever you're subtracting all of this, whenever you subtract particularly this negative, that's then going to be, you're adding it on. So we've then got, if we simplify this, 2x squared subtract 4x squared, that's going to be minus 2x squared. We've then got our minus 121. And then we've got our plus 44x. So that's simplifying the left-hand side, and that's equal to 23. Okay, so we want to solve this quadratic equation. So what I'm actually going to do is I'm going to bring everything to the right-hand side, because here we've got minus 2x squared. So I'm going to add 2x squared to both sides. I'm going to add 121 to both sides, and I'm going to take away 44x from both sides. And whenever we do that, on the left-hand side, we'll be left with 0. And then on the right-hand side, we have 23. And then we're adding 2x squared, so add 2x squared. We're adding 121, so add 121. And we're subtracting 44x, so subtract 44x. Okay, and then if we have a look at this, and let's put our 2x squared at the front, so 2x squared. We've then got minus 44x, and then in terms of the numbers on the end, we had 23, we're adding 121, so it's plus 144. Okay, so we've now got this equation, we need to solve it. I'm actually going to divide it all by 2, so that'll give us 0 equals x squared minus, and then half of this will be minus 22x, and then plus 72. Okay, so we've now got our equation, and we need to solve it. Now, it's a calculator question, which means, will it factorize, or will it be the quadratic formula? I'm going to try to factorize it to begin with. The question doesn't actually mention anything in terms of giving your answer to so many decimal places, and that'll be a big hint that you're using a quadratic formula. So I'm going to try to factorize it to begin with. So we've got 0 equals, and then in brackets, And I'm going to put x at the front of both brackets, and I want to find two numbers that multiply together to be 72, and whenever we add them together we get minus 22. And it's a calculator paper, so you can try doing that on your calculator and get those answers. And I have found it to be minus 18 and minus 4, because minus 18 times minus 4 is 72, and minus 18 plus minus 4 would be equal to minus 22. So that's it. So it means that x is equal to 18, or x is equal to 4. So there are two values of x. Now let's find our values of y. So we find here we have y was equal to 11 subtract 2x, so y is equal to 11 subtract 2x. So whenever we have x is equal to 18, we're going to have when x is equal to 18, we're going to have that y is equal to 11 subtract 2 times 18, and it's a calculator paper, so you can work that out in your calculator, and you'll get the answer to be minus 25. So y equals minus 25. So whenever x is equal to 18, y is equal to minus 25. And whenever x is 4, so when x equals 4, we're going to have y equals 11 subtract 2 times 4. 2 times 4 is 8, so we're going to have 11 take away 8, which is 3, so y is equal to 3. So whenever x is equal to 4, y is equal to 3. So there are two solutions, that x equals 18 and y equals minus 25, or x equals 4 and y equals 3. And there are solutions. Okay, let's have a look at our next question, question number 7. And this is a non-calculator question, so I'm just putting down my calculator. And we've got the equations x squared plus y squared equals 25. So we've got a circle with radius 5. If you know the equation of a circle, you know why that's the case. And then we've got x plus y equals 7, so this straight line. And we've been asked to solve these equations. So let's make x or y the subject of the linear one. And I'm going to make x a subject, so I'm going to take away y and take away y. And on the left hand side we'll just be left with x, and on the right hand side we're going to have 7 subtract y. So we've made x subject of this equation, this linear, and now we're going to substitute that into the equation at the top, the nonlinear, the equation of a circle. So instead of x we're going to write 7 subtract y. So we're going to have in brackets 7 subtract y, close brackets, squared, then plus y squared equals 25, just replacing the x with 7 minus y. Now we want to expand this and simplify it, so let's write the bracket out twice, 7 minus y, and then 7 minus y, and then plus y squared equals 25. And then expanding our bracket, 7 times 7 is 49. 7 times minus y would be minus 7y. Minus y times 7 would be minus 7y. And then minus y times minus y, well, negative times a negative is a positive, so it'll be plus y squared. And then we've still got our plus y squared. Make sure you don't forget that one. And that's equal to 25. And now let's simplify this. So we're going to have 49 subtract, and we've got minus 7y is going to be minus 14y. And then we've got plus y squared, that's 2y squared, and that's equal to 25. And now we want to solve this, so let's rearrange this. So we're going to have 2y squared minus 14y plus 49 equals 25. Okay, so we want to solve this, so let's make it equal 0. So let's take away 25 from both sides. So we're going to get the 2y squared minus 14y plus 24 is equal to 0. And also, let's divide everything by 2 here. So we're going to get that y squared minus 7y plus 12 equals 0. So let's factorize this and solve it. So we've got y squared minus 7y plus 12 equals 0. So putting our brackets down, so factorizing equals 0, we're going to have y. And we want two numbers that times together to be 12 and add together to be minus 7. So I'm thinking minus 3 and minus 4. So that means that y is equal to 3 or y is equal to 4. So there are two values for y. Now we know that x is equal to 7 minus y. So whenever y is equal to 3, we're going to have that x is equal to 7 minus 3. So x is equal to 4 there. Whenever y is equal to 4, you're going to have that x is equal to 7 minus y. So 7 minus 4. And then x is equal to 3. So there are solutions, that x is equal to 4 and y is equal to 3, or x is equal to 3 and y is equal to 4, and there are solutions. And if this question asked you for the coordinates where this straight line intersected the circle, they would be 4, 3 and also 3, 4, and that's it. Okay, let's have a look at our next question, question number 8. So question number 8 is find the coordinates of the point where the line y equals 2x minus 2 and the curve y equals x squared minus 5 intersect. So we've got this straight line and this quadratic, and we want to find the coordinates of the points. So because there's points, there's going to be 2 points where the line and the curve intersect. And what's quite nice about this question is we've got our nonlinear, the quadratic, and we've got the linear, and y is already the subject of the linear. Y is equal to 2x minus 2. So in this question, we can go straight to the nonlinear, and we can replace the y with 2x minus 2. because we know that y is equal to 2x minus 2. So let's do that. So we've got y is equal to x squared minus 5, and we're going to replace the y, we're going to substitute in 2x minus 2 for that y. So we're going to have 2x minus 2 is equal to x squared minus 5. Now we can just solve this. So let's take away 2x from both sides to begin with. So on the left hand side we'll be left with minus 2, and on the right hand side we're going to have x squared minus 5 minus 2x. And then let's add 2 to both sides. So we're going to have 0 equals. And then on the right hand side we're going to have x squared. We had minus 5, we're adding 2, so it's now going to be minus 3 minus 2x. And let's just rearrange the order of this. So we've got 0 equals x squared, and then we've got minus 2x minus 3. Okay, so we've now got a quadratic. Let's factorize and solve it. So 0 equals, and then if we factorize this, we're going to have x and x. And we want two numbers that times together to be minus 3 and add together to be minus 2. So I'm thinking minus 3 and 1, because minus 3 times 1 is minus 3, and minus 3 plus 1 is minus 2. So that means our solutions will be x equals 3 and x equals, so we've got our two values for x. Now we just need to find our values for y. And remember that y is equal to 2x minus 2. So we're just going to substitute in 3, and we're also going to substitute in minus 1, and that'll tell us our values for y. So whenever x equals 3, we're going to have y is equal to 2 times 3, and then we've got minus 2. 2 times 3 is 6, minus 2 would be 4, so y equals 4. So that's our first point. We've got the point 3, 4. So that's 3, 4. And then in terms of our second point, well, whenever x is equal to minus 1, we've got y is equal to 2 times x minus 2. So it's going to be 2 times x, which is minus 1, minus 2. 2 times minus 1 will be minus 2. Taking away another 2 will be minus 4. So that's y is equal to minus 4. So our second point will be the point minus 1, minus 4. So minus 1, minus 4. And that's it. There are points 3, 4, and minus 1, minus 4. And that's it. So that's fantastic. We've found where this straight line intersects the curve. It intersects at these 2 points. And that's it. Okay, let's have a look at our next question, question number 9. So question number 9 says, solve the equations x squared minus y squared equals 7 and 2y is equal to 2 plus x. Okay, so in terms of this question, I'm going to make x the subject of the linear, so I'm going to take away 2 and take away 2 from both sides of this equation. So on the left-hand side, we'll have 2y minus 2, and on the right-hand side, we'll just be left with x. And if we turn this around, we're going to have that x is equal to 2y minus 2. Okay, so we've made x the subject of this. Now we need to substitute that into the nonlinear. So we've got, instead of x squared, we're going to write this squared. So it's going to be 2y minus 2, close bracket, squared. So instead of x squared, we're writing this squared. Subtract y squared is equal to 7. Okay, now let's expand this. So let's write the bracket out twice. 2y minus 2, close brackets, 2y minus 2, close brackets, and then subtract y squared is equal to 7. Okay, now let's expand our brackets. 2y times 2y would be 4y squared. 2y times minus 2 would be minus 4y. Minus 2 times 2y would be minus 4y. And minus 2 times minus 2 would be plus 4. And then we've still got our take away y squared. And that's equal to 7. Okay, now let's simplify this. So we've got 4y squared, take away y squared, that's going to be 3y squared. We've got minus 4y, that's minus 8y, and we've still got plus 4, and that's equal to 7. Okay, and then if we take away 7 from both sides of this equation to get it equal to 0, we're going to have 3y squared minus 8y. And then we had 4, we're taking away 7, so it's going to be minus 3. And on the right hand side, we had 7, we're taking away 7, so that's equal to 0. So we've now got this quadratic equation. So let's write it down, and I'm just going to write it down up here, just to give us a bit more room. 3y squared minus 8y minus 3 is equal to 0. Okay, so we've now got our quadratic equation, and we now need to solve this to find our values for y. Now it's a calculator question, which means that, perhaps we could use the quadratic formula if we wanted to, but I'm going to try and factorize it to begin with. So I'm going to write 3y in one bracket and y in the other bracket, and then that's equal to 0. And we're going to try to look for two numbers that multiply together to be minus 3, and whenever we put them in the brackets and we expand it, we're going to get minus 8y. So I'm thinking if we put the minus 3 in that bracket, because we're going to do 3 times minus 3, which is be minus 9y. And then if we put the plus 1 there, let's check this. 3y times y would be 3y squared. 3y times minus 3 would be minus 9y. Plus 1y would be minus 8y. That's fantastic. And then we've got our minus 3 on the end. And that's equal to 0. Fantastic. Okay, so that means here that y is equal to 3. Or here we've got 3y plus 1 is equal to 0. This bracket is equal to 0. If we take away 1 and take away 1, we're going to get that 3y is equal to minus 1. And then if we divide by 3, we're going to get that y is equal to minus a third. Because minus 1 divided by 3 would be minus a third. So there are two values for y. This is fantastic. So if we have a look here, we had that x is equal to 2y minus 2. So x is equal to 2y minus 2. Let's find the values for x whenever y is equal to minus a third and y is equal to 3. So let's start off with y is equal to minus a third. So then x would be equal to 2 times y, so that's 2 times minus a third, and then subtract 2. And it's a calculator paper, so that's quite nice. So you can do this on the calculator, and you get that x is equal to minus 8 thirds. So whenever y is equal to minus a third, x is equal to minus 8 thirds. And also, let's work out our value for x whenever y is equal to 3. So whenever y is equal to 3, x is equal to 2 times y, take away 2. So it's going to be 2 times 3, take away 2. 2 times 3 is 6, take away 2 is 4, so x is equal to 4. So that's fantastic, we've got our solutions. So whenever x is equal to minus 8 thirds, y is equal to minus a third, or whenever x is equal to 4, y is equal to 3, and there are solutions. Okay, let's have a look at our next question, question number 10. So question number 10 says, how many points of intersection does the circle x squared plus y squared equals 18 have with the line x plus y equals 6? So here we've got a circle and we've got a straight line, and they could not intersect. You could have a circle and then a straight line, and the straight line never meets the circle, so there could be no points of intersection. It could be that the line touches the circle and carries on, so that's a tangent, so it would have 1 point of intersection. Or it could be that the straight line passes through the circle and then you're going to get 2 points of intersection. So let's work this out. So what I'm going to do is I'm actually going to treat it like the equations we've been looking at so far and try and solve it. And by finding out the number of points in terms of our solutions, that'll tell us our answer. So we've got our linear x plus y is equal to 6. So let's make x a subject to this. So let's take away y and take away y. So we're going to get that x is equal to 6 minus y. So we've made x a subject to the equation. We're now going to substitute that into the nonlinear, or the equation of the circle. So instead of x, we're going to write 6 minus y. So instead of x squared, it's going to be 6 minus y squared. And then we've got plus y squared is equal to 18. So we've now got this. Let's expand our bracket. So let's write the bracket out twice, 6 minus y, and then in bracket 6 minus y, and then plus y squared is equal to 18. So we've got this. Let's expand our bracket. 6 times 6 is 36. 6 times minus y be minus 6y. Minus y times 6 be minus 6y. And minus y times minus y, that's going to be plus y squared. And then we've still got plus y squared, and that is equal to 18. So we've now got this. Let's simplify this on the left-hand side to begin with. So we've got y squared plus y squared, that's 2y squared. We've got minus 6y minus 6y, that's minus 12y. And we've got 36, that's plus 36. And that is equal to 18. And now, whenever we want to solve a quadratic like this, it's great if it equals 0. So let's take away 18 from both sides. So we're going to get 2y squared minus 12y. And then if we take 18 away from both sides, we'll again then get 36 take away 18 is 18. And then on the right-hand side, that's equal to 0. And now, if we have a look at this, let's divide everything through by 2. So we'd have y squared minus 6y plus 9 is equal to 0. Okay, so we've now got this equation, let's solve it. I'm just going to write up here, y squared minus 6y plus 9 equals 0. So let's factorize this and let's solve this equation. So we'd have bracket, 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 bracket equals 0. Okay, so let's try and factorize it. So we've got y squared, so I'm going to try a y and a y. And then we want to find two numbers that multiply together to be 9 and add together to be minus 6. So I'm thinking minus 3 and minus 3. And let's just check this. Y times y is y squared. Y times minus 3 is minus 3y. And another minus 3y will be minus 6y. And then we've got minus 3 times minus 3 is 9. Fantastic. So we've now got these brackets. Let's solve our equation. So here we're going to have y is equal to 3. And also here you've got y is equal to 3. So that means there is only one value for y. And that means if there's only one value for y, there'll only be one value for x. Let's find it anyway. We don't need to do this, but let's find it. At this point, we can see there's just going to be 1 point of intersection, but let's just find it and see where it is. So x is equal to 6 minus y. So x is equal to 6 minus 3. So x is equal to 3. So the point 3, 3, where x is equal to 3 and y is equal to 3, that's the point where the straight line and the circle intersect. So the question says, how many points of intersection does the circle have with the line? The answer will be 1, just this point here. So let's write that down, 1. Okay, let's have a look at our next question, question number 11. So question number 11 says, solve the equations x squared plus y squared equals 45 and 5x minus 3y equals 21. Okay, so let's start off by looking at our linear, and I'm going to make y the subject here. You could make x the subject if you wanted to, but I'm going to make y the subject. We've got 5x minus 3y equals 21. I want to make y the subject. The reason actually I do want to make y the subject is I can see at some point I'm going to divide by 3, and if I do 21 divided by 3, it'll give me a whole number, whereas if I divide by 5, it'll give me a decimal. decimal, so that's why I'm making y the subject. So I'm going to add 3y, and I'm going to add 3y. On the left-hand side, we're just going to have 5x, and on the right-hand side, we're going to have 21 plus 3y. Now we want to make y the subject, so we want to get rid of this 21, so let's take away 21 and take away 21. On the left hand side we'll then have 5x minus 21, and on the right hand side we'll be left with 3y. And now if we divide by 3, if we divide everything by 3, we're going to get, well, if we divide the left-hand side by 3, we're going to have 5x divided by 3, so it's going to be 5 over 3x, or you could write 5x over 3, however you wish to write it. You could even write it as a decimal if you wanted to, 1.666666, and so on. X, I'm going to write it as 5 over 3x, because 5 divided by 3 is 5/3 x. And then we had minus 21, we're dividing that by 3, so it's going to be minus 7, and that equals y. So we now have that y is equal to 5/3 x minus 7. So this is fantastic. We can now substitute that into our nonlinear. So we've got x squared plus y squared is equal to 45. We're going to replace the y with 5/3 x minus 7. So we're going to have here x squared plus, and then instead of y, we're going to write this in a bracket. So 5/3 x minus 7 squared, and then equals 45. Now, with a bracket squared, remember we write it beside itself, so we've got here x squared plus, and then we're going to write the bracket twice, so 5/3 x minus 7, and then 5/3 x minus 7, and then close brackets, equals 45. And now let's expand this. So we've got x squared, and then we've got 5/3 x times 5/3 x. Well, you can do this on your calculator, 5/3 times 5/3, or you can just know that you multiply the numerators and multiply the denominators. So 5 times 5 is 25, and 3 times 3 is 9. So it's going to be 25 over 9 x squared. Next, we've got 5/3 x times minus 7. And again, it's a calculator paper, so you can do it in your calculator. And you're going to get that's equal to 35 over 3. So 5/3 x times minus 7 will be minus 35 over 3x. And we've got the same again here, so that's going to be another minus 35 over 3x. And then finally, we've got minus 7 times minus 7, so it's going to be plus 49. And that equals 45. And now let's simplify this. So we're going to have, we've got x squared, which is 1x squared, and we're going to add 25 over 9x squared. So I'm just going to do my calculator 1 plus 25 over 9, and that equals 34 over 9 x squared. Now we've got minus 35 over 3x, subtract 35 over 3x. So I'm going to do minus 35 over 3, subtract 35 over 3, and that is equal to minus 70 over 3x. And then we've got our plus 49 on the end, so plus 49, and that is equal to 45. So we're getting there. It looks quite messy, but we're getting there. Now we want to get it equals 0, so let's take away 45 from both sides. So we're going to get 34 over 9 x squared minus 70 over 3x. And then if we take away 45 from both sides, we're going to get plus 4 equals, and then on the side 0. Now here we want to solve this equation. Now in terms of solving this equation, and I'm going to use the quadratic formula, but in terms of solving this equation, some of these numbers, because you've got 34 over 9 and 70 over 3 and so on, they're not that nice. So what I'm going to do is I'm going to multiply the whole equation through by 9. Because this says 34 divided by 9. So if I times everything by 9, I can get rid of this 9 on the denominator here. 9 is also divisible by 3, so I get rid of this, and so on. So I'm going to multiply everything through by 9. So you can do it in your calculator. You could do 34 over 9 times 9, and you're going to get 34, so it's 34x squared. Now we're going to do a minus 70 over 3 times 9, that's minus 210x. And then if we do 4 times 9, that's plus 36, and that is equal to 0. And actually, just before we use the quadratic formula and call this A, B, and C, I've just noticed that all the numbers are even, so we can divide everything by 2 here. So we get 17x squared minus 105x plus 18 is equal to 0. So this is fantastic. We can now find our values for A, B, and C and use the quadratic formula and solve this quadratic equation. So we're going to let A equal 17. We're going to let B equal minus 105, and we're going to let C equal 18. And so we've got our values for A, B, and C, and the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So let's substitute our values and see what we get. So we've got here x equals minus b. Well, b was minus 105, so minus b would be, then make it positive, so it's going to be 105 plus or minus, and then we've got the square root of b squared, so that would be minus 105 squared. I'll work that out in a minute, minus, and I like to put this all in a bracket here. So then we've got 4 multiplied by a, which is 17, multiplied by c, which is 18. Close brackets. So that's what's under the square root, and that's actually the numerator completed, all divided by 2a, so 2 times 17. So 2 times 17. So let's work this out and see what we get. Let's just do a little bit of simplifying here. So we're going to have x equals 105 plus or minus the square root of, and then minus 105 squared, well, I'll type that into my calculator, minus 105 close bracket squared is equal to 11,025. Remember, a negative times a negative is a positive. Subtract, and then I'll work out what's in the brackets here. So 4 times 17 times 18 is equal to 1,224. And then that's all divided by 2 times 17 is 34. Now at this point, I'm actually just going to type this into my calculator. So x is equal to, and I'm going to type in 105 plus the square root of this over 34. And then I'm going to type in 105 minus the square root of this over 34. So whenever I type in on my numerator 105 plus the square root of 11,025 minus 1,224, all divided by 34, I get an answer of 6. So x is equal to 6. That's fantastic. Perhaps this would have factorized actually, but at least doing it this way, we didn't need to bother factorizing this 17x squared minus 105x plus 18. And then if we try this again, but with a subtract, so if actually on my calculator, or x equals, just change the plus sign to a subtract, hit this one here. So I'm going to do 105 minus that, I get an answer of 3/17. So 3/17. So yeah, that would have factorized. So here we've got our values of x. Now let's find our values for y. So if we scroll up, we're told that y was equal to 5/3 x minus 7. So remember our values for x, so x was equal to 6, that was our first value for x. So let's substitute that in, so we'd have y is equal to 5/3 multiplied by 6, then subtract 7, just replacing this x with 6. And then if we work this out, we're going to get the y is equal to 3. So that's fantastic. So that's one of our solutions. Whenever x is equal to 6, y is equal to 3. Or, now remember, x could also be equal to 3/17. So here, if x was equal to 3/17, then if we substitute that into our y equals 5/3 x minus 7, we were going to get y is equal to 5/3 multiplied by 3/17, close brackets, subtract 7. So again, let's work this out in our calculator. And that is equal to, y is equal to minus 114 over 17. So we've got our value for x and our value for y. Now the question says to give our answer to an appropriate degree of accuracy. So let's have a look at these and see what they are as decimal numbers. So we'll have x is equal to, so 3/17, so 3/17 is equal to, 3/17 is equal to 0.1764705 8 and so on. So I'm going to round this to 4 decimal places. So x is equal to 0.1765 to 4 decimal places. And in terms of our value for y, our minus 114 over 17, we'd have that's equal to minus 6.70588 2 and so on. And again, let's round that to 4 decimal places. So y would be equal to minus 6.705. And if we've got 8, so we're going to round up 9. So there are two solutions, that x equals 6 and y equals 3, or x equals 0.1765 and y equals minus 6.7059. And we've rounded those to 4 decimal places. Now we could have actually left them as fractions and left it as x equals 3/17 and y equals minus 114 over 17. But I've just written them like that. And that's it. We've solved the simultaneous equations. Okay, let's have a look at our next question. Okay, let's have a look at our next question, question number 12. And question number 12 says, find the coordinates of the points where the line y equals 3x minus 3 and the curve y equals 2x squared minus 8x plus 2 intersect. So we want to find where this curve and this straight line intersect, or where this straight line crosses this curve. And it's a calculator question. I've actually tried the question, and I can actually do it without a calculator, so don't actually need a calculator for this one if you don't want to use one, but you can use one if you want to. But I've actually just completed it without one. So we've got y equals 3x minus 3 and y equals 2x squared minus 8x plus 2. So we want to make x or y the subject of the linear. Y is already the subject of the linear, so that's fantastic. Y equals 3x minus 3. So we're going to replace the y in the non-linear with 3x minus 3. So instead of writing y equals 2x squared minus 8x plus 2, we're going to replace this y with 3x minus 3 equals 2x squared minus 8x plus 2. Okay, so we've got this quadratic and we want to bring everything to one side. So I'm going to make the left-hand side 0. So I'm going to take away 3x and take away 3x. So on the left-hand side, we'll be left with minus 3. And then on the right-hand side, we'll have 2x squared. And then we have minus 8x minus another 3x. That's going to be minus 11x. And then we've got plus 2. Now we want to get rid of this minus 3. So we're going to add 3 and add 3. So on the left-hand side, we'll have 0. And on the right-hand side, we're going to get 2x squared minus 11x, and then we had 2, we're adding 3, so that'll be plus 5. So we've now got this quadratic. Now I've actually completed this question already and I factorized this, so that's quite nice. We don't need to use the quadratic formula in this question. So 0 equals, so let's factorize this. So we've got 2x squared, so let's do 2x and x. And we want to find two numbers that multiply together to be 5. And whenever we expand our brackets, we're going to get minus 11x. Now, because this is minus 11x, we know these have to both be negative, because whenever we times a negative by a negative, we get the positive that we want. But whenever we expand our brackets, we get that minus 11x. Now we want two numbers that times together to be 5. So I'm thinking the minus 5 on this side and the 1 on this side. The reason is whenever we do 2 times minus 5, that's minus 10x, and then the minus another x will be minus 11x. So let's just check this. 2x times x is 2x squared. 2x times minus 5 is minus 10x. Minus another x, whenever we times that together, will be minus 11x, and then we've got our plus 5. Okay, so now let's solve this. So we want to get our solution. So here we would have 2x minus 1 equals 0. If we add 1 to both sides, we get 2x equals 1, and divide by 2, we're going to get the x equals a half, or 0.5. And here, x is equal to 5. So there are two values of x, that x equals a half, or x equals 5. Now we know that y is equal to 3 times x subtract 3. So whenever you've got x is equal to half, we're going to have y equals 3 times a half minus 3. 3 times a half, or 3 times 0.5, would be 1.5. Take away 3 would be minus 1.5. So y equals minus 1.5, or minus 1.5, or minus 3 over 2. And here, whenever x is equal to 5, if we substitute that in, we're going to get y is equal to 3 times 5. Take away 3. 3 times 5 is 15. Take away 3 would be 12. So y equals 12. And that's it. There are solutions. Or actually it says find the coordinates of the points. So be careful there. So here we're going to have this point here. The coordinates of this point will be a half. And then in terms of the y, we could write minus 1.5. I'm going to write minus 1.5. Or you could write it as a half and minus 3 over 2. Or we could even write it as a 0.5 and minus 1.5. However you wish to write the coordinates of that particular point. They're all the same. And here in terms of this point, that's just going to be 5, 12. And that's it. So the coordinates of the point where they intersect. So I'm going to go for 5, 12. And also I'm going to go for a half and minus 1.5. And that's it. They're the coordinates of the 2 points where the curve and the line intersect. And that's it. Okay, let's have a look at our last question, question number 13. So question number 13 says, solve the equations y equals 3x squared plus 8x minus 9 and 2x plus y equals 15. We've been asked to give our answers to one decimal place. Okay, so here, this is a calculator question, and I've just completed it, and you actually need to use the quadratic formula, and whenever you do it this time, it will be decimal numbers you get as an answer, and so you will need a calculator for this question. Okay, so let's start off by making y the subject of this linear. So here we've got 2x plus y equals 15, so 2x plus y equals 15. If we take away 2x from both sides, take away 2x and take away 2x, on the left hand side we'll have y, and on the right hand side we're going to have 15, take away 2x. So we've made y the subject of the linear. Now let's substitute that into the nonlinear, or this quadratic. So instead of y, we've got 15 minus 2x. So it's going to be 15 minus 2x equals, and then we've got 3x squared plus 8x minus 9. So we've replaced the y in the nonlinear with our 15 minus 2x. Okay, now let's solve this. So let's bring everything to the right hand side. So if we add 2x to both sides, so add 2x and add 2x, we're going to be left with on the left hand side 15, and on the right hand side we'll have 3x squared plus 10x minus 9, adding 2x there. And then if we take away 15 and take away 15, we're going to get on the left hand side 0, which is what we wanted. And on the right hand side, we're going to have 3x squared plus 10x. We had minus 9, we're taking away another 15, so it'll be minus 24. Fantastic. So we've now got this. Now it's a calculator question, so let's use the quadratic formula to solve this. So I'm going to let A equal 3, I'm going to let B equal 10, and I'm going to let C equal minus 24. That's the coefficient of x squared is your A, the coefficient of x is your B, and the constant on the end is our C, our minus 24. So let's write down the quadratic formula. So x equals minus B plus or minus the square root of B squared minus 4AC, all divided by 2A. Okay, so let's substitute in our values. So x equals minus B, so B is 10, so minus B will be minus 10, plus or minus the square root of B squared, so it's going to be 10 squared, that's 100. Subtract 4AC, so I'm going to put this in a bracket, 4 times A, which is 3, times C, which is minus 24. Close brackets. And that's all divided by 2A. A is equal to 3, so 2A would be double 3 would be 6. Fantastic. Okay, now let's simplify this a little bit more. So we've got x equals minus 10 plus or minus the square root of, and let's work out what this is. So 100, and I'm going to do on my calculator, 100 minus, and then in brackets, 4 times 3 times minus 24, close brackets. That's equal to 388, because you're subtracting a negative here, so it's going to be 388 whenever you work it out, all divided by 6. So this is fantastic. We can now find our values for x. So actually, let's go back up a bit. Okay, so let's find our values for x. So here we have x will be equal to minus 10 plus the square root of 388 divided by 6, or x equals minus 10 minus the square root of 388 divided by 6. Just writing this plus or minus as a plus sign and then a minus sign. So let's work out our two solutions. So x equals, so let's work this one out. So let's press our fraction button, minus 10 plus the square root of 388, all divided by 6, and when we press equals, we get that as a decimal number to be 1.616285934. Now I'm not going to round this yet because I'm going to need to use this to work out the value for y, and here x will be equal to, just changing that plus sign to a minus sign on the numerator, so it will be now x will be equal to minus 4.949619267. So we've got our values for x. Now let's find our values for y. So let's go back up. Y is equal to 15 minus 2x. So I'm just going to write our values for x here again. X equals, okay, so we've got our two values for x, and I've written them out in full here, and we've got our y. Y is equal to 15 subtract 2x. So here, whenever x is equal to 1.616 and so on, y will be equal to 15 subtract 2 times that 1.616 and so on. So let's type that into our calculator. So 15 subtract 2 times 1.616285934 is equal to 11.767428813. So we've got a pair of solutions there. X equals 1.616 and so on, and y equals 11.767 and so on. And with our other solution here, whenever x is equal to minus 4.9496 and so on, well, we know that y is equal to 15 subtract 2 times x, so that's going to be 2 times that minus 4.9496 and so on. And when we work that out, we get y to be equal to 15 subtract 2 times minus 4.9496199267, close brackets. And whenever you work that out, you get that to be y is to be equal to 24.89923853. Fantastic. So we've got our solutions. They're just quite long. We've been asked to give our answers to one decimal place, so let's round them. Okay, so here, if we go down to our solutions, I'm actually just going to make a little box here for our answers. So here, let's put our answers in here, just so it's a bit tidier from our working out. It's a bit hard whenever you're doing it on a computer to see how you're setting it all out. So here, x equals, let's round our first one to one decimal place, 1.61, so it's going to be 1.6, and y equals 11.76, so we're going to round up 11.8, so 11.8. That's our first pair of values for x and y, or x equals, then we had minus 4.94, so it's going to be minus 4.9, the 4 is not going to round it up, and for the y we would have 24 point, we had 8.9, so it's going to round up 24.9, so 24.9. And that's it, that's our solutions. And that's it. So these have been the video solutions to the simultaneous practice questions in Corbettmaths, and they're the ones with linear and non-linear simultaneous equations, so a bit harder than the easier simultaneous equations. And so in terms of this video, we're focused on the video solutions to the practice questions. If you need any extra help on this topic, if you go to Corbettmaths and scroll down to video number 298, there's a dedicated video tutorial on this topic. Alternatively, scan this QR code. But in this video, we're focused on the video solutions to the practice questions. I really hope you found it useful. If you have found it useful, please like this video and please subscribe to the YouTube channel. Thank you. Cheers. Bye.